All right, question 12. 12 is a fun one. You might know this is actually a identity, right? So e to the natural log of x is just going to be equal to x. So this is like saying the limits as x approaches e of x, which is just simply going to be e. Now, if you just plug this in with direct substitution, you'll get the same answer, where we'll get e to the natural log of e. The natural log of e is 1. So we just get e to the first power, which I'm told is equal to e. If you look at 13, so now we're going with some limits as we approach infinity. So this is all about domination. So which one of these things grows faster, e to the x or x to the ninth? Exponentials win, so the top grows faster than the bottom. So this means we're going to shoot off towards infinity. In 14, which one of these things grows faster? Well, natural logs are one of the slowest growing functions that we have. So the bottom dominates. This thing's going to approach 0. If I look at 15, well, all I need to do with these polynomials is look at the degrees. So I'm going to get, I don't even know how it does that anymore. So my bottom, my denominator is bigger than my top. So that means that we're going to go off towards 0. The bottom dominates. If we look at 16, ooh, so this might be something that you would not know. So if you're ever stuck, you should graph these things out, although the top's going to win. So let's look at these things. Right, so I have, if I go to Desmos and I graph something like x raised to the x, we get kind of this weird looking but exponential function. If I have e raised to the x squared, I get this function here. Right, and we could, if we wanted, we could graph these two, or we could take the fraction of these two, right? So I could take x divided by x, and then I could divide this whole thing by e raised to the x power. All right, and if we zoom out a lot, oh, I lied to you. The exponential in the bottom ones. So if I zoom out a lot, this thing never starts shooting back up because it's trailing off to 0, because e to the x squared is dominating the x raised to the x. All right, so that means this thing goes off towards 0. Oh yeah, there's a way that we can do that. There's a smart way of doing this. So if you looked at 17, so it's 17, sine we know fluctuates between -1 and 1. Natural log, we know eventually goes off towards infinity. So the bottom is going to dominate. This is going to be 0. You could also use like the squeeze theorem if you wanted to, right? You could say something like, so this would be like a -1 sine of x, 1, then kind of dividing both these things by the natural log of x. Right, so, and then when we take the limits of these things, again, this goes off towards 0, that goes off towards 0. So by the squeeze theorem, sine of x over natural log of x would also go off towards 0. In 18, so if we're taking the square root, right, as x gets big, the only thing that really lives on here is going to be the square root of x to the third power, which would be like having x to the 3/2. In the denominator, we have x squared. So what dominates? 2 is bigger than 3/2, so the bottom dominates. We're going to get 0. In 19, so we only care about the highest powers. So those powers cancel out. We're left with 3/4. So that's what our limit's going to be. It does not matter that we're going to negative infinity. Our function trails off. It has a horizontal asymptote at 3/4. In question 20, the degree of the top is bigger than the degree of the bottom. So this thing is going to go off towards infinity. And then here, if we go off towards negative infinity, well, the absolute value of x, we know looks like this. It's shooting off towards positive infinity. X is shooting off towards negative infinity. You may or may not know that the absolute value is actually a piecewise function. So the absolute value is -x for x less than 0, and it's positive x for x greater than or equal to 0. Basically says that the absolute value is a line with a slope of 1 or -1, depending on which quadrant it's in. So if we're going off towards negative infinity, we know that this function is acting like negative x. So this is like saying negative x over x. These functions co-dominate. They have the same powers. So negative x over x is going to be -1. That's what our limit is going to be.